How are you all? So today we will be discussing Poisson and normal distributions. So with this we will be completing our core part of the mathematical physics. Whatever things are there in the core part, I think all of them have been covered. Did we miss anything from the core part? I don't think so. Did we miss anything from the core part? Look, this particular session, good morning Ajay, Rani. Okay, so this particular session is going to be very much useful. Questions may come from this, and with this topic we will be completing our core part, as I have already told you. So I gave you some homework problem from the binomial distribution, and I have also provided you the solution. I hope you have understood those homework problems. So today we will start with Poisson distribution. Actually, if you see, Gaussian distribution or normal distribution, Gaussian or normal, both are same thing. Okay, so normal distribution is like more generalized probability distribution. Binomial and Poisson are like special case of the normal distribution. Under some approximation, your binomial and Poisson distribution will convert into normal distribution. So this is one thing you should keep in mind. So if I talk about Poisson distribution, look, today's many of the slides I have prepared in this form. Okay, I will not just keep on writing, that will take a lot of time. That is why I have just written them in a beautiful manner, and you will get you will get this PDF, so you don't need to worry. So if you want to write few things, you can write, otherwise this PDF will be uploaded to the course folder. Okay, let us talk about Poisson distribution. It is a limiting form of binomial distribution, as I told you. It can be used under this following condition: the number of trials are infinitely large, n tends to infinity. In case of binomial distribution, the number of trials was large but finite, but here it is infinitely large. The constant probability of success for each trial is infinitesimally small, p tends to 0. In the case of binomial, what we have seen, p was like not tending to 0, like for the case of tossing a coin, getting a head, p was half, right? For other examples we took, p was nearly half, 0.4, maybe 0.6, but not equals, not tending to 0. But in case of Poisson distribution, the constant probability of success for each trial is infinitesimally small. But this product, you see, n tends to infinity, p tends to 0, but this product np, it will be a finite quantity. Okay, if a random experiment is repeated n times, n tends to infinity, it denotes like n is very large. The probability that event A will occur r times is equals to e to the power minus m, m to the power r by r factorial, where m is the mean of the distribution. Sometimes this m is represented by lambda. Okay, sometimes people always also write probability of getting this successful event at r times is equals to e to the power minus lambda, lambda to the power r divided by r factorial. We also see this form where lambda is the mean of the distribution. The same form, only symbol has been changed. So mainly you have to use this formula, P of r is equals to e to the power minus m to the power r by r factorial. This is the heart of the Poisson distribution. Good morning, Murli. Let me know if you have understood. Do you understand what is this infinitesimally small? These are the ideal cases of Poisson distribution. You can imagine tossing a coin, getting a head, probability is half. But if I say that at a particular junction, a bus passes, let's say one bus passes in a minute. So what is the probability? Let's say one bus passes in an hour. So what is the probability that one bus passes in a minute? 1 by 60. One bus passes in 1 hour. So in 1 minute, how many buses? What is the probability of getting a bus? 1 by 60. So as you can see, for tossing a coin, getting a head, the probability was half, and here it is 1 by 60. So this is way less than this half. So that is why if you assign it as P, this is tending to 0, very small number. Is it clear? Now for every distribution, probability distribution, we need to know the mean, variance and standard deviation. So what is the mean of this Poisson distribution? As you can see, it is denoted by m, and m is the product of this number of trials multiplied by the number of successful events. This P, constant probability of success. So NP denotes the mean. Chalo, I hope this is done, or I will provide the PDF. Okay, you don't need to write many things. Mean and standard deviation. Mean of the distribution, this one is very important. Mu is equals to, mean means average or expected average value of x. This is denoted by n times p. This is equals to our m. Okay. What about the variance? Variance of the distribution, sigma square. This is also equals to mp. So variance and mean are same in case of Poisson distribution. What about the standard deviation? Standard deviation of the distribution. So obviously it is square root of sigma square. So sigma root over np. So in this distribution there is nothing like q, only p is involved, n and p. In this expression also you can see e to the power minus m to the power r by r factorial. M is np. So whenever you want to apply this formula, you will see how many number of trials and you will see the probability of success. You will take the product, that will give you m, and you know how many times you get the successful event. From that you can utilize this formula. And from these two things you can also conclude some other things. Let's say this variance is nothing but your delta x square, na? So this is x square average minus x average square. So here x average, as you can see, it is NP. X square average is equals to NP times 1 plus NP. And obviously sigma square, which is delta x square. So x square average, so NP plus NP square minus NP square. So this is equals to NP, and hence the standard deviation sigma is equals to root over NP. Every day I start with a hot coffee, right? In the beginning I start with a hot coffee, but eventually it turns into a cold coffee. Okay, let us take an example, and for the same problem, if we apply binomial distribution and probability distribution, let's see how the results gets varied. So I am giving you a problem. You will apply binomial distribution once, then you will apply Poisson distribution, and you will see what kind of difference you get in the results. Is it done? Is there any question, anybody? If anybody has any question. Deep has also come. Ajay, I think Ajay sent good morning message, na? Where is Ajay? Okay, do this problem. Look, 10% of the tools produced in a certain manufacturing process turn out to be defective. Find the probability that in a sample of 10 tools chosen at random, exactly 2 will be defective. By using, first you use binomial distribution, secondly you use Poisson distribution. So here successful event is getting a defective product. Okay. So here you can imagine that successful event is the getting a defective tool. Getting a defective tool. Would you give it a try? First you calculate with Poisson and then binomial, or you can also do the reverse. First apply binomial distribution. Using binomial distribution, what will be the things he given here? Look, the probability of getting a defective tool, this is the probability of success. Probability of getting a defective tool is P. 10% of the tools, 10 by 100, 0.1. For binomial probability 0.1937, very good. For Poisson, find out, that is correct, 0.1937 exactly. So Q, what will be Q? Probability of not getting a defective tool. Q is equals to 1 minus P, 1 minus 0.1, 0.9, R is 2. Okay, first sample of 10 tools chosen. So this number of trial. So n is equals to 10. Exactly 2 will be defective. So how many successful event? This is R. R is equals to 2. Okay. So probability of getting 2 defective tools out of 10 tools is 10 C2 P to the power 2 Q to the power 10 minus 2. Okay, and if you calculate, we will get 0.1937. Now if you apply the Poisson distribution, what value are you getting? Using Poisson distribution. So P, the P value of binomial is same as the P value of Poisson. Okay. So when you use Poisson, here also your P is the probability of success, that is 0.1. N is 10. So M, that is equals to the product of N and P, 10 times 0.1. So this is 1, and R is equals to 2 as usual. So probability of getting R is equals to 2 is equals to e to the power minus m to the power r by r factorial. This is the formula, right? E to the power minus m to the power r times the r factorial. At r is equals to 2. So e to the power minus 1 to the power 2 divided by 2 factorial. So this is how much you are getting? 0.1839, Ajay, exactly 0.1839. So according to you, which one is more accurate here? What do you think? Which one is more accurate? 1 by e to factorial, one by 2e actually, है ना? E to the power minus 1 is 1 by e, 1 is 1 square is 1, so 2 factorial is 2, so actually 1 by 2e. Yes, Murli. So 1 by 2e 0.1839, so you can write it 1 by 2e 1839. Now Deep, you are saying binomial distribution. Why? Can you tell me the reason? Why do you think so? I also think so, that binomial will be more accurate. Without knowing the actual result, we can say that binomial is more accurate here. Why? because the Poisson distribution will be more accurate if the number of trials is large and the probability of success will be less, but here it is more closer to the binomial distribution. Number of trials is only 10 and p is also 0.1, that's quite large. Understood everybody? Harry, Ajay, Mulli. N does not tend to infinity. Infinity is like I should use the term, it is very large, not infinity. Infinity, like meaning of infinity is something different. Number of trials are very large, just avoid this term infinity whenever, but in the theory it is there, otherwise how will you call it a finite quantity? That is also there. Okay, leave it like that, but infinity does not necessarily mean like it is very huge, well, because when you talk about number of trials, it is although large, but it is way larger as compared to, let's say, 100 or 150. To develop the theory, we need to write n tends to infinity, and so np is a finite quantity, but you can understand what we mean here. Okay, look at this problem now. Try to do this problem. I think if you can do this problem, it means you have understood how to use Poisson's distribution. Use Poisson distribution. There are on average 10 buses per hour at a point. 10 buses per hour at a point, but at random times. The probability that there are no buses in 5 minutes is closest to. So you just read it like this. There are on average 20 buses per hour. So per hour also means in 60 minutes. Yes, sorry, what did I read? There are on average 20 buses in 60 minutes. So what is the probability that there are no buses? Means bus equals to 0 in 5 minutes. You just need to understand what is the value of R, what is the value of M, what is the value of N. So you need to find out value of N and value of P, then an R. N, P, R you need to find out, then your problem is solved. So here what is the successful event? Event of success. So you can imagine passing of a bus in a minute, that you can consider as a successful event. P is equals to 1 by 3. Very good, Murli. So P is the chance of getting a bus in a minute, है ना? Tell me the answer quickly. C. Okay, let's see the solution. So the probability that a bus will pass in 1 minute is equals to 20 buses passes in 60 minutes. So 1/3 bus passes in a minute. The probability that there are no buses in 5 minutes. So number of trials is n is equals to 5 minutes. No buses means r is equals to 0. So this is the number of success. Number of successful events. R is equals to 0. So there will be no bus passing in 5 minutes will be this. So e to the power minus m to the power r by r factorial, e to the power minus np to the power r by r factorial, n into p, this is p. So n into p is 5/3 e to the power minus 5/3 to the power 0 divided by 0 factorial. So e to the power minus 5/3, whatever is the answer, that is the answer. What is e to the power minus 5/3? Where is my calculator? Calculate e to the power minus 5/3. What are you getting? E to the power minus 5/3. मेरा कैलकुलेटर कहाँ गया भाई? .19 you are getting? I also think so. .1888, yes, option D. चलो आगे बढ़े. Assume that the probability of an individual coal miner being killed in a mine accident during a year is 1/2400. So this is a very small, okay na? use appropriate statistical distribution to calculate the probability that in a mine employing 200 miners there will be at least one fatal accident in a year, means there will be one killing. So in your problem in the examination they will not mention, maybe they may not mention that you use Poisson distribution, but by reading the question you have to understand. So you will see that number of trials is not very small, and most importantly p value is very small. In that scenario you will understand that Poisson distribution you have to apply, because the other distribution, normal distribution, will not come into picture in this problem like this. Either Poisson will come or binomial will come, and you can easily differentiate. I think in binomial there will be two possibilities, clear two possibilities you will see. So probability of an individual coal miner being killed in a minute in a mine accident during a year is 1 by 2400. So p is already given to you, 1 by 2400. Employing 200 miners means it is n. There will be at least one fatal accident in a year. So you need to decode this line. There will be at least one fatal accident in a year. How many of you understood the question? Understanding the question is important. In 1 year, the probability that a coal miner will get killed is 1 by 2400. So this is p, no doubt in this. Now here it says that if you employ 200 miners, there will be at least one fatal accident. What does it mean? It means within a year one miner will definitely get killed, 2 miners may also get killed, 3 miners may also get killed. Up to how many miners may get killed in a year for this case? Minimum limit is 1, at least one fatal accident. So there may be 2, 3, 4, 5. So what is the maximum number of fatal accident can take place for this case? How will you use Poisson distribution here? Think about it. This type of problem may come in your examination. Not able to think? P is equals to 1 by 2400, n is 200, at least one fatal accident, m is equals to n times p, 1 by 2400 times 200. So this is 1 by 12, small number. 1 minus e to the power minus 1 by 12. Yes, Deep. What is the logic? The logic is probability that at least one fatal accident will happen, one miner will get killed. Probability of at least one is equals to probability of one miner get killed, or 2 miners get killed, or 3 miners get killed, and so on, or all 200 miners will get killed, at least means. At most 200, because 200 miners you have employed. So it may possible that all the 200 miners get killed. So when you see or, what you use? Probability of 1 plus probability of 2 plus probability of 3 and so on up to probability of 200. If you individually calculate all the terms like P of 1, then you have to utilize this. You know the formula of P of r, e to the power minus m to the power r by r factorial. So you have to be smart in calculating things. So if you start applying this formula for each value, like first you put r equals to 1 and m value we already know 1 by 12, that will remain same for all the cases. Then if you put r is equals to 2 in this expression, r equals to 3 in this expression. So is it feasible to do? No. So what you can do, you can make it 1 minus probability that no fatal accident. You see, at least one fatal accident, that is one event, then at least then 2 fatal accidents, that is another event, 3 fatal accidents, that is another event, then all 200 fatal accident, that is another event. But one event you are missing, that there may be no fatal incident, that is also an event. And if you add all those probabilities, what do you get? You get 1. So total probability is 1 minus this probability that none get killed. Is this thing clear or not? Tell me guys. This is a very crucial concept. .08. So you can see the percentage, only there is 8% chance. There is only 8% chance that at least one fatal accident will happen. So that is quite negligible. Let's go to the next page then, if you have understood. Look, I find these questions very interesting and enjoyable. I think you also find this probability chapter is very enjoyable, isn't it? As compared to complex analysis and all, these problems are fun to do. Using Poisson distribution, find the probability that the ace of spades will be drawn from a pack of well shuffled cards at least once in 104 consecutive trials. That is why I have prepared a dedicated page or dedicated slide for cards on the last class, na? Last class, I think. Ace of spades. Do it quickly. What is P here? What is P here? P is the one by 13. As I think about it more critically, should it be 1 by 13? How many ace of spades are there in the whole deck? How many ace of spades? This is only one card now. So when you are drawing it from 52 cards, what is the chance? If it were saying that the ace, that one ace has been drawn from a pack, then you could have said that 4 aces are there, so 4 by 52. But here it is specifically mentioning about one card, ace of spades, so it will be 1 by 52. Okay. The probability of getting the ace of spades, P is equals to 1 upon 52. Number of trials, n is equals to 104. Here also at least once in 104 consecutive trials. So let's first calculate m. M is equals to the product of NP, 104 times 1 by 52. So this is 2, and hence probability of getting a e to the power minus m to the power r by r factorial. So e to the power minus 2 to the power r upon r factorial. So probability of getting ace of spade at least once is like, in a similar way it will go on up to 104. So what is the meaning of this? It's like you have a deck of card, you are drawing, you can get, and you are drawing 104 times. Okay, na? You took out a card, keep it back, well shuffled. Took out a card, keep it back, and you are noting whether you are getting ace of spades or not. So there may be chance that you will get no ace in 104 tiles. You can get 1 times. You can get it 2 times, you can get it 3 times, you can get it 4 times, you can get all 104 times. There is a chance, obviously this chance is very small, like 104 consecutive times, each time you are getting the same 104, that is chance is very rare, na? But it will contribute. So this is nothing but 1 minus P r equals to 0. So 1 minus e to the power minus 2 to the power 0 by 0 factorial. So this is 1 minus 1 by e square, 1 minus 0.135, so 0.865, option 4. Okay, So I think Poisson distribution you understand. This type of problem will generally come, and I think you are now in a good position to tackle these problems. Ajay, Harry, Deep, Murli, are you feeling confident now? Let us go for Gaussian or normal distribution. This is my personal favorite and you will feel amused. Gaussian is like such a curve you see in almost all physical processes. You must have seen a reel on YouTube, maybe on Instagram, a machine, some this kind of rectangular box was there, okay na? And above side maybe balls are released and there are packets, okay, and there are balls of different colors are there and packets are there. You must have seen this, I think, in reel or somewhere. So when you release these balls of different color, it is observed that particular colors are filling up different tubes, and surprisingly they were making a distribution like this. This is your Gaussian distribution. R is equals to 0, 1 minus P R equals to 0. R equals to 0 means you take out a card 104 times from a deck of card and in no time you get a subspeeds. So that is that event. The probability of not getting a subspeeds in 104 trials. Total probability is 1. Probability of getting at least once, probability of getting at least 2 times, at least 3 times, at least 4 times, 10 times, no time, total 1. So 1 minus probability of getting no speeds, this. Getting it, Harry, or any other question? Simple harmonic motion. Okay, let us go for this Gaussian distribution. Gaussian has another name, normal distribution. Normal distribution is a continuous distribution. It is derived as the limiting case of the binomial distribution for large values of n. P and Q are not very small. So binomial, you see, like finite values of n, P, Q are large. For Poisson, P, Q are very small, P is very small, and here it is, they are small but not very small. The normal distribution is given by this expression, 1 by sigma root 2 pi e to the power minus x minus mu square by 2 sigma square. So if you can represent any function in this form, then whatever number will come here beside root over 2 pi, that will be the standard deviation sigma, and whatever term will come here, this mu, that mu is the mean, okay, mean and standard deviation. So probability of getting a random variable between x1 and x2, then you will take the integration. So it is like this. सो ये थोड़ा सा कैसा बन गया ये, दैट्स ओके। So if you specify two values, let's say x1 and x2, so probability of getting the value between x1 and x2 is represented by this. So it is talking about this area, no? Now here you see x minus mu whole square by 2 sigma square. So if you substitute z with x minus mu by sigma, then you get f of z is equals to 1 by root 2 pi to the power minus z square by 2. Mean becomes 0, means mu becomes 0 and standard deviation sigma becomes 1. So 1 by root 2 pi to the power minus z square by 2. So under this condition, where you get mean equals to 0, standard deviation equals to 1, with this replacement, this is known as the standard form of normal distribution. We will talk about this standard normal distribution little more in the next slide. This function you must have seen many times before actually reading this Gaussian or normal distribution. You must have seen in different applications. Most of the physical processes follow this Gaussian pattern. It's so fascinating, and when we will be doing central limit theorem, then you will be amazed more. How is this possible? Nature has been designed in such a way, like everything almost ultimately turns into a Gaussian. That is why there is a saying that the Almighty God is a mathematician. From the perspective of the creation of planets, universe, and everything are there in a at their stable position. Without mathematical calculation, how is that possible? Look, placing the moon, the earth and the sun at appropriate positions without mathematical calculation. Do you imagine? So that is why people say like this. Look, standard normal distribution. The standard normal distribution is a specific case of the normal distribution where you make this transformation z is equals to x minus x average by sigma. So x average is mu, right? Just try to understand this. This PDF I will provide, so don't worry. Z is equals to x minus mu by sigma or x minus x average. X average is the mean, sigma is the standard deviation. Total area under the standard normal curve is 1, because total probability is 1, so total area under the curve will be 1, which represents the entire probability. That is what I was telling you. The curve is symmetrical about z equals to 0. The curve is symmetrical about z equals to 0, which corresponding to the mean of the distribution. This midpoint z equals to 0 corresponding to the mean. Dividing the area into two parts. As you can see, one area is this and another area is this. So dividing the area into two parts, 0.5 to the left, 0.5 to the right, and total 1. The area between z is equals to 0 and any other value of z can be found using a standard normal distribution table or z table. Now what is this? Because you see, at the different values of z, you can get the value of f of z, right? Now what is the value of, let's say at some z1, what is the value of f of z? So there is a table where for each z1, for each z, value of fz is given. That is the z table. So in your examination, the required values will be given. What do I mean? You may require the value of f of z at particular z1, that values will be provided. You will not be provided the whole z table, otherwise you can get the values of fz corresponding to z1, but they will specifically give you the value which are required. Fibonacci series, yes, Fibonacci series is another very fascinating thing. It shows that the nature doesn't work so randomly. There is a pattern. In nature there are many things which will just amaze you, So you will think, how is this possible? So much precision. Okay, now let's talk about the normal curve properties, normal curve and its properties. So first of all, here x average, mean is mu, and x square average is equals to mu square plus sigma square, because this is quite obvious, na? This formula you will be utilizing many times. This is sigma square. In probability in quantum mechanics, we are going to use this. So sigma is equals to delta x. That is a variance. You will get back this same result. Why should I write? Sigma square equals to sigma square. Doesn't make sense. So delta x square, you will get a sigma square, delta x is equals to sigma. So let's say this is a normal curve. So what does this value represent? X equals to mu. If you talk about sigma, this is mu plus sigma, and symmetrically opposite, mu minus sigma, and so on. So it is symmetrical about x equals to mu and extended up to minus infinity to plus infinity. The curve has a peak at x equals to mu. So what is the peak value, can you tell me? The normal curve attains a peak at x equals to mu, and the peak value is, if you put x equals to mu in this original expression, then this will become 0. So e to the power 0 is 1. So 1 by sigma root 2 pi होगा ना. So fx maximum 1 by sigma times root 2 pi. God is the greatest mathematician. Not very good, it is greatest. Acha, tell me, if I give you three curves, let's say one curve is like this, another curve, let's say like this, another one, let's say like this. Tell me, if I say the standard deviation sigma values, it is sigma 1, sigma 2, then sigma 3. Can you tell me the order? Let's say mean mu is equals to 0. So sigma 1, sigma 2, sigma 3, what will be, how will you arrange? Should it be less or greater or equal? What should I give, like this or like this, or any other possibilities? Tell me quickly. Sigma 1 greater than sigma 2 greater than sigma 3, or just the opposite? You see, what does this sigma represent? This portion is sigma. So sigma 1 is less, na? The spread is less. Here you see the spread, here you see the spread, for here you see the spread. So sigma is inversely proportional to the peak height now. So if peak height is more, means sigma is less, है ना? So it is peak height is proportional to 1 by sigma. So sigma 1 should be less than, and actually it is seen in this picture now. Is it not seen? As I told you, this value represents sigma. So here obviously sigma value will be less. Sigma 2 will be greater than sigma 1. Sigma 3 is more flat. So sigma 3 will be the highest one. Yes. So this thing has been shown in this picture more experimentally. Normal distribution with mu equals to 0 and various values of sigma. Guys, let me tell you, these things are, whenever you do it for the first time, it may appear to be easy, but once many things you cover, there is a chance that you will find it confusing. So it is recommended, must recommended, that you revise regularly. Now let me give you some of the very important theorem based on this normal distribution. This is theorem number 1. If the random variable x, y have the same normal distributions, that is the same mean value and variance. So mean value gives you where the position of the peak lies, variance gives you how much flatter or widened it is, or sharp or flat it is, gives you a peak. From the variance or sigma value you can get to know like whether the curve is like this or the curve is like this. Okay. So if xy denotes the random variable with same normal distribution, then z is equals to x plus y has a normal distribution with twice the mean value, twice the variance of x and y. X, y are independent variable with same distribution, so that their sum will have, so mean of z is equals to mean of x plus mean of y. So both x and y, the mean are same mean value, so it is mu plus mu 2 mu. Variance of z is equals to variance of x plus variance of y, sigma square plus sigma square 2 sigma square. So 2 times the variance, twice the variance of x and y. So if you denote this previous normal distribution as n of mu sigma square, mu is the mean, sigma square is the variance. So for z it will be 2 mu 2 sigma square. If the random variables x, y have the same normal distributions, that is the same mean value and variance, then z is equals to x plus y has normal distribution with twice the mean and twice the variance. Is it understood? Can you go to the next theorem? Harry, understood? Ajay, Deep, Murli. Look at this. So this normal curve is like bell looking curve, na? This is looking like a bell curve, bell shaped curve, it is also said. Bell you have seen, na? In 3D. So normal curve is a bell shaped curve. In the limit n tends to infinity, so that mean value np tends to infinity, the binomial distribution becomes Gauss normal distribution. Actually, the mathematician who discovered this, who invented or discovered, whatever you say, normal distribution, his name was Gauss. So Gauss distribution or normal distribution. So previously or in today's world also, there is a tendency that whenever some scientist discovers something groundbreaking, then he always try to associate himself with that discovery, na? Sometimes scientist associates their country to the new extraordinary discovery. So it happens throughout this history. The limit n tends to infinity, np tends to infinity. So in that case, binomial distribution becomes Gauss normal distribution. This is the result of central limit theorem. Now, what is the central limit theorem? We'll talk about it more in later, which assert that the sum of a large number of independent and identically distributed random variables, each with finite mean and variance, will approximate a normal distribution regardless of the original distribution. For the timing, you can just read it out. We'll talk about it separately. In the context of binomial distribution, as n becomes large, np is sufficiently large, the binomial distribution, which is discrete, starts to resemble the continuous bell curve of the normal distribution. Last line, you see, binomial distribution I have also shown you, like it is like given like this, so very discrete, है ना? Like this. So we will see that when this n becomes very large, it will tend to follow the Gaussian or normal distribution. Sum of a large number of independent and identically distributed random variables for the timing, ignore this one. This we will have a better version of this. Okay, ignore this time for the timing. We have better version of it. There you will understand. Just focus on this part and this part. In the limit n tends to infinity, np tends to infinity, and the binomial distribution becomes a normal distribution. And in case of binomial distribution, n becomes very large, np is sufficiently large, binomial distribution, which is discrete, becomes a continuous bell curve of the normal distribution. So if I show you the picture goes like this. So you see this rectangular shaped portion is the normal distributed curve. So you can see at large number it will take up the shape of a bell curve. So if you just reduce this number of trials, if you make very large, so this will be continuous. Now you imagine that making this width of the rectangular very small, very closer to them, so it will be a smooth normal curve. Similarly, third theorem involves the Poisson distribution for large n value binomial Poisson both will converge into normal distribution. For large n and mean value mu, the Poisson distribution approaches Gaussian distribution. As you can see, this plots the Gaussian distribution when the value of m is 1 small. M is equals to n into p, है ना? So more n means more m. So increasing value of m means increasing value of n. So as you can see, what happens to my throat? This is the Poisson curve for m is equals to 1. Data points are, you can see, 1, 2, 3, 4, 5 less. Yeah. And the product n times p is 1. Product is increasing means number of points is also increasing, number of trials is also increasing. So if you make it from 1 to 4, you get a curve like this, and you can see for 10 it has taken the shape of the normal curve. So for large n value, you can see both binomial and Poisson distribution takes the form of normal curve. This is what it is. Now we will be going for central limit theorem. What does it say? It says that, let's say we have different kinds of this distribution. It may be normal, it may be binomial, it may be exponential, or any kind of distribution you have. Let's say you have a distribution, any kind of distribution there may be. So for each distribution you can get a mu value, right? For this one also you can get a mean value. You can get a mean value for this curve, let's say. You can get a mean value for this curve, let's say. So if you plot all of these means at a single graph at very large value of n, so you take out the mean values from infinitely many samples, and if you plot it in a graph, that will resemble the normal curve. You can take the sample from an exponential distribution or any kind of distribution, whatever be the shape. If you plot their mean, ultimately you will get a normal curve. This is what central limit theorem says. Getting my point? Let's say the curve you have like this. So for this curve also you will get a mu, x average. If you have a curve like this, you will get a mu. You get a curve like this, you will get a mu. So if you take out this kind of mu from an infinitely large number of samples, and if you plot it on a graph, that will take up the form of normal distribution or Gaussian distribution. This is what is called central limit theorem. Now, the central limit theorem states that for a sufficiently large sample size n, the distribution of the sample mean approaches a normal distribution regardless of the shape of the original popular distribution. So as you can see in this picture, you have been given a random distribution. This is not normal. Is this a normal distribution? No. This is an arbitrary distribution, and for this population distribution you can find out one mean. Okay. Now you consider such n number of such distribution. So for each distribution you will get one mean, x average. Now if you plot those mean, let's say one mean you get here, another mean you get here, here with p values. If you plot it, you will get a Gaussian. So you can see the distribution of the sample means distribution of the x average takes the form of a normal distribution. I hope central limit theorem is clear to everyone. And the standard deviation, as you can see, it is sigma by root over n cap. Sigma by root over n. So to summarize, you can say although any random distribution may not be normal, but average of many distribution will be a normal. This is little bit critical concept. Actually, I think this is the last concept of this chapter. So I think you can understand. Central limit theorem, how many of you have understood? Let me reiterate it again. Let's say we have different samples. Okay. So for each sample you will get distribution. For each distribution you have mean value. Now if you plot all those means into a graph, that will take the form of a normal curve. Provided it is sufficiently large sample size. Mathematically, let x1, x2, xn denote a statistical sample of size n from a population with expected value mu and finite positive variance sigma square. Let x bar x average denote the sample mean, which is itself a random variable. So here x average is behaving like a variable. You can see we have plotted x average. You are plotting all the means. Then as limit n tends to infinity of the distribution, xn average minus mu by sigma by root over n cap. So if you remember, z, what did you take? X minus mu by sigma you took now when standardize the normal distribution. If you have forgotten, let me just show you once again. As you can see, z is equals to x minus mu by sigma. So when applying central limit theorem, this sigma becomes sigma by root over n. Yeah, you see sigma has been replaced by sigma by root over n. So for this one normal curve, x was the variable, but when you take the average of n number of samples, x average is the new variable. So that is why xn average minus mu divided by sigma by root over n. So remember this one, sigma by root over n. It is also a normal distribution with mean value 0 and variance 1. Tell me if you are getting something or is it going over your head? Harry, Deep, Ajay, Murli, are you able to understand or is it going over your head? Tell me. Got my point? You all were silent. I thought it is going over your head. So it is like this. We may have different kinds of distribution. I am just showing you a small part. So there are infinite number of curves. If you take the mean values of all these curves, you will get mean from each curve, and if you plot it, it will take up the form of this. This is what central limit theorem says. So generally, I think in previous year, have you seen any question from central limit theorem? This is a concept. There may be some conceptual question from this. Mathematical question you may not get. Okay, let's do some mathematics. I think you guys are more interested in mathematics. This is a good concept actually, central limit theorem. The concept needs to be understood. Now the kind of problem is set is quite different. Mean value of random variable x with probability density p of x is equals to this is. Do it quickly. Mean value. So obviously this is your normal distribution. Mean value of normal distribution is at the peak. So here you have to find out the peak position. So at the peak position, probability is maximum, है ना? Do it quickly. B option, B or C. Please see whether it is C. For the mean value dp by dx at x equals to x average equals to 0. So dp by dx you find first 1 upon sigma root 2 pi, constant term not giving us any trouble. Let's keep them as it is, x square plus mu x divided by 2 sigma square, okay, multiplied by minus 2x plus mu or minus mu. This is equals to 0. Exponential term cannot be 0, so we can say that 2x plus mu equals to 0. X is equals to minus mu by 2. Option C. Clear, everyone? Now let us go for a little different type of problem. Okay. Look at this problem. A manufacturer of envelopes knows that the weight of the envelopes is normally distributed with mean 1.5 gram, 1.9 gram and variance 0.01 gram. Calculate the number of envelopes weighing 2 gram or more, 2.1 gram or more can be expected in a given packet of 1000 envelopes respectively. Given if t is a normal variable, then phi between 0 to 1 is 0.3413, phi between 0 to 2 is 0.4772. I hope you are not getting this problem. I expect this is a new kind of problem. Are you able to understand anything after reading? What is trying to say? Look, it is like a normal distribution. Manufacturer envelopes knows that the weight of the envelope is normally distributed with mean 1.9 gram. So you have represent the distribution of weight in this normal curve, by this normal curve, and which has a mean at 1.9 gram and variance 0.01 gram. So it will be little bit squeezed. Calculate the number of envelope weighing 2 gram or more. So if you say this is 1.9 gram, so 2 gram or more, it is like calculating this part, na? Okay, sorry, yes, that was correct. If this is 1, let's say this is 2, so 2 gram or more is like this, 2.1 gram or more, so little more. Got my point? You see, the total area under the curve is 1, and what each point represent on the curve, each point represent the probability, na? Each point on the curve f of x, what does it represent? It represents the probability at that particular value of x. So if you get the probability and if you multiply with the number, you get a number, है ना? So if you can find out the probability of getting envelopes weighing more than 2 gram, and if you multiply with 1000 the total number of envelopes, then you will get the envelopes which are weighing 2 gram or more. Try to understand, a little critical concept. Let us try to do, then we'll explain side by side. First of all, let us write what is given to us. Here mu value is given, mu is equals to 1.9 gram. Variance means sigma square, it is given to u 0.01 gram. So you have to calculate the variable x 2 grams or more. So we have to standardize this by using this normal variable z, है ना? What was the formula? X minus mu upon sigma. So this is equals to, why we need to convert this? Because this is the value given in the normal table. For normal, you need to convert it into the normal variable first. Standard form of normal distribution by replacing z is equals to x minus mu by sigma. So for this, you see, what will be the mu? Mu will be 0, na? Z square means z minus mu, so z minus 0 whole square. So you can say mu is equals to 0. For this distribution, it was x minus mu whole square. So that is why mean was mu. So if after substituting z is equals to x minus mu by sigma, you are only getting z square. It means the mean is at z is equals to 0. Are you getting this point or not? Too many things I am writing. So z is equals to x minus mu by sigma. So 2 minus 1.9 by sigma. Sigma is square root of 0.01. This is your sigma square. So this is 0.1 divided by 0.1, so 1. So for x equals to 2 gram or more, so x equals to 2 corresponds to z equals to 1. So let us try to draw this. Try to understand it very carefully, okay? If you don't focus carefully, you will not be able to understand. So when you do this substitution, z is equals to x minus mu by sigma, where do you get this mean? At z is equals to 0, na? The mean will be at z equals to 0. Now x equals to 2 corresponds to z is equals to 1. So where is your z is equals to 1? Your z is equals to 1, maybe this is z is equals to 0, so z is equals to 1 is this, isn't it? So x is equals to 2 gram or more corresponds to this region. Corresponds to this regions. Is it making sense? So probability of getting more than x equals to 2 means more than z is equals to 1. Same thing. So this is nothing but the area right to z is equals to 1. It is talking about this area. So what is that area? As I have already told you that this line, it separates the symmetric curve into two parts. one is this part, another one is this part, and total probability means total area under the curve is 1, means 0.5 portion is at left side of z equals to 0 and 0.5 is on the right side. So if you want to calculate this much of area, what you have to do, you have to subtract 0.5 minus this. So area right to z equals to 1 is equals to 0.5. So that is the total right side area minus the area between z is equals to 0 and z is equals to 1, है ना, this is 1. So 0.5 minus area between z is equals to 0 and z equals to 1 is given 0.3413, 0.3413. So this will give you 0.1587. So what you get? You get probability P. What is this? Probability of getting an envelope weighing 2 grams or more. Now total 1000 envelopes, means if you consider this whole distribution, then total envelope is 1000. So for this much of probability, what will be the total number of envelopes? Therefore number of envelopes heavier than 2 gram in a sample of 1000 in a given packet of 1000 envelopes. Will be, if you just multiply with the probability this 1000, that will give you the exact number of packets, around 158.7. so we can say around 159 packets will be heavier than 2 gram or more. Clear? So using this same logic, can you find out what will be the number of envelopes with 2.1 gram or more? So for 2.1 gram and more, what will be the scenario? How the picture will change? This is lesson number 1 for 2 gram or more. So for 2.1 gram or more. So obviously a number, this number will be less or greater or equal. If you are calculating for 2.1 gram, will it be less or greater or equal? Less, obviously, because less area will be covered. 2.1 gram you need to convert into Z, है ना? So 2.1, that is the minimum value of Z you are calculating, ना? So can you do this? $159, so 23 will come, you will get. So just do this, the second part. Second part you do and let me know if you are able to get it or not. Look, not complicated. If you have understood it systematically, then it will appear to very easy, nothing complicated. For the second case, what is the value of z you are getting? When z increases, curve will cover less area. Yes. What is the z value for the second case? Tell me quickly, what is the z value for the second case, where x is 2.1 gram or more? So x equals to 2.1 gram you have to take. So x minus mu by sigma, 2.1 minus mu is 1.9 divided by sigma root over 0.01. This is 0.2 by 0.1, 2. So you can imagine how the graph will look like. बहुत ही गंदा कलर चूज किया है मैंने. So this was z is equals to 1. Let's say your z is equals to 2 is somewhere here. So we need to now cover this much of area. So obviously it is less. So probability with z is equals to z greater than 2, this is the area right to z is equals to 2. Yeah? So it is like 0.5 minus the area between z equals to 0 to 2. Z equals to 0 to 2, it is given 0.4772. So these values are taken from the z table which I was talking about, z table. So it is not possible to give you the whole total table. So only those values which will be necessary for solving the problem will be given to you, 0.4772. So this will come out at 0.0228, and required number of envelopes out of 1000, so 1000 into 0.0228, this will come out approximately 22.8, means approximately 23. Option 1. समझ में आया दोस्तों? Have you got it? Another problem we will be doing. We need to first form the standard normal curve. For that you need to replace this z is equals to x minus mu by lambda. Once you do this, you know that your mean is situated at z is equals to 0. When you do not substitute this, your mean is at any mean, okay na? It is x equals to mu, any arbitrary. But once you make this substitution, z is equals to x minus mu by sigma, your mean becomes z is equals to 0. That is the advantage, है ना? चलो आगे बढ़ते हैं. Let's do this problem दोस्तों. This is the last problem. A manufacturer knows from experience that the resistance of resistors he produces is normal with mean mu is equals to 100 ohms and standard deviation sigma is equals to 2 ohms. What percentage of resistors will have resistance between 98 ohms and 102 ohms? Clear? Provided that if z is a normal variable, then probability 0 to 1 is 0.3413. Okay. Look, if the probability between 0 to 1 is 0.3413 and as the curve is symmetrical, it also means that the probability of between -1 to 0, that should be same, na? Do you agree? Because the curve is symmetrical about z equals to 0. 1. Do the calculation. Without doing the calculation, how will you say? Mu is given 100 ohms, sigma is given 2 ohms. What percentage of resistors will have resistance between 98 ohms? So, corresponding to 98 ohm, you need to find out the z value. Corresponding to 102 ohm, you need to find out the z value. So, you will get z1 and z2, and from that you can see what is the percentage. Do it quickly. So, these are like x values. So, he knows that ultimately the manufacturer will get a normal curve. So, this is 0. So, it is like f of z versus z. In both cases, z value is 1. For 98, I think you will get -1. Na? It is shown, na? 98 minus 100 negative number you are coming. How in both cases it becomes 1? In one case it will be +1, another case it will be -1. Na? 2 times 0.3413. Yes. Very good. Very good. So, I think you have understood this. Given mu is equals to 100 ohms, standard deviation sigma is equals to 2 ohms, x1 is equals to 98 ohm, x2 is equals to 102 ohms. So, z1 is equals to x1 minus mu by sigma, that is equals to 98 minus 100 divided by divided by 2 minus 1. So, z is equals to -1. Let us say this is your z is equals to -1. z2 is x2 minus mu by sigma, 102 minus 100 by 2 is equals to +1. So, this is your z is equals to +1. So, this much of area is involved here. Now, probability is 0.3413 for 0 to 1. So, obviously 2 times of this will be the total area under this, है ना? So, area between z1 is equals to -1 and z2 is equals to +1 is equals to 2 times 0.3413, 0.6826. So if this is the probability, so in terms of percentage you can say it is 68.26 percentage. 3. So this kind of problem you can expect. So although not many questions came from this, I have given you any kind of problem, probable questions which may be given in your upcoming exams. These are taken from standard textbooks, so it may happen that you get with little bit of modification. With this, the core part of our mathematical physics is over. In the advanced part, we have Green's theorem, Green's function, numerical and partial. These many things are left. Diffusion, Brownian motion and all those things. So mainly Green's function and numerical. These two things you need to cover, because 5 marks question may come from those. So let us end the session here, and let me guys tell you one special thing. Actually, I am relocating to a new place, okay. So maybe for few days I will not be able to take classes. At first I have to make sure I have to make new setup. First I have to find a room, then I have to make a setup. So few days I will not be taking classes, and as soon as possible, if I make all the arrangement, I will take the classes. Okay, we can take some additional classes to cover up this. Okay, Harry, Murli, Ajay, Deep, I will give you the update why I am relocating and all, but for the time being, you know, I have to relocate immediately. Maybe within few days I will let you know about all the details. Till then, you keep revising, and if I get time, I will make the Sunday test, but there may be some chance if I don't get sufficient time, then it may not be possible. But I will try my best to make the question for you. Okay, nothing like that, medical emergency and all, nothing like that. So something is good, you understand. Chalo, with this note, yes, in the meantime you can take this time to revise, because the core part is a significant portion. We have covered it in very less time actually. A lot of things we have discussed. So you take this 3-4 days maybe to revise all those things and see the PIQs whether you are able to do it. I think most of the PIQs you will be able to do it, and try to solve them in the meantime. And once I am good to go, I will let you know. Till then, bye bye, take care guys, thank you very much, see you soon, very soon. All the updates I will be giving you on the WhatsApp group. Chalo, bye bye.